we are asked if a and b are positive integers, is a minus b cubed even? And then we're told, we're given a couple of statements. So this is an odds and evens question, asking us about the properties of odd and even numbers, but it's made a little bit more complicated by the addition of these exponents. So there's actually a very simple way of dealing with odds and even questions that involve exponents. And the strategy is as follows. So in odds and evens questions involving exponents, remove the exponents. It's a very simple strategy. What do I mean by remove the exponents? Well, very simply, if you're told that, for example, x cubed is even, you can just remove the exponent. If x cubed is even, that means that x itself is even. Or, for example, if x squared times y cubed times z to the fourth is odd, again, you can just remove the exponents. And what that tells you is that x times y times z is odd. Or in other words, that all of them have to be odd if you remember your rules of exponents. Similarly, if you're asked whether, for example, w to the fifth is, let's say, odd, you can remove the exponent and just rephrase the question as, is w odd? This is because exponents don't alter the property of odd and even in any way for any number. So in this question, we're asked, is a minus b cubed even? We can get rid of the cube, and really the question then just becomes, is a minus b even? So they're really just asking us about the difference of a and b. Statement number one says a plus b is even. If you remember your properties from one of the previous videos, the properties of odd and evens, the same rules hold for both adding and subtracting when you're dealing with odds and evens questions. So if a plus b is even, that means that a minus b is even as well. So statement one is sufficient. And you can check this with some numbers. For example, 6 plus 4 is even, and as we see, 6 minus 4 is even as well. Same thing with, let's say, 11 plus 7 is even. And if we just take those same two numbers but subtract them, 11 minus 7, we get an even result as well. This is 18, this is 4, and this one was 10, and this is 2, all even. So if you know that a plus b is even, you know that a minus b is even, and statement 1 is sufficient. Statement 2 says a plus b times a minus b is even. What we can, although this may seem like we might not have enough information because now we're dealing with a plus b, a minus b, or there's various ways of thinking about this. We'll throw in some strategy from algebra here as well. This is when you're multiplying two expressions like this, the sum of two numbers and the difference of two numbers, so a plus b and a minus b. This is known as the product of a sum and a difference, and that results in what's known as the difference of two squares, meaning that a plus b times a minus b, when we multiply these out using the FOIL method, we'll get a squared minus b squared. So we're told that a squared minus b squared is even. It's a good thing as you maybe review your algebra to remember or to memorize that a plus b times a minus b always gives you a squared minus b squared. And now when we're told that a squared minus b squared is even, we can go back to our rule and see that, okay, well, as exponents, we can get rid of it. So if a squared minus b squared is even, that's the same as saying a minus b is even. That answers our question, and therefore statement 2 is also sufficient, and the answer is